Right, today in Algebra 2, we're going to look at section 7.4, graphing sine and cosine. So first, let's talk about what a periodic function is. So a periodic function is a function for which the outputs repeat at regular intervals. When a function is periodic, f of x equals f of x plus p for some number p. The smallest such value of p is called the period. To understand the period of a function, you should use a table of values with radian measures on the unit circle to graph f of x equals the sine of x. Okay? So if I look at 0, okay, so I'm going to plug all of these in for x. So this is asking me, what's the sine of 0? So the sine of 0, the y is 0. This is asking me, what's the sine at pi over 2? So the sine at pi over 2 is 1. The sine at pi is 0. The sine at 3 pi over 2 is -1. The sine at 2 pi is 0. The sine at 5 pi over 2 is 1. Notice that it goes a pattern. 0, 1, 0, -1, 0, 1. It starts to repeat itself here, okay? So here it starts to repeat. So it did an entire pattern from 0 to 2 pi. So if I plot these points, so here 0, 0, we're going to call this 1 and this -1. At pi over 2, I'm at 1. At pi, I'm at 0. 3 pi over 2, I'm at -1. 2 pi, I'm at 0. 5 pi over 2, I would be back at 1. It's going to repeat itself, so then I know at 3 pi, I'm going to be back at 0. So this, and again, I could put arrows on both ends because I know that it's going to continue on. Okay. It says, notice that the y values start to repeat themselves after x equals 2 pi. For this periodic function, sine of x plus 2 pi equals the sine of x for all x. The period of the function of sine of x is 2 pi. That's where it starts to repeat itself. The midline is the horizontal line halfway between the maximum and minimum points of the graph. The amplitude is the distance from the midline to the maximum or minimum value of the graph. This is also known as our height. The minimum and maximum values of -1 and 1. Right? So again, if we notice here we were at 0, 1, 0, -1, 0. Okay? So my amplitude, it shows, is the height from the midline up. So the amplitude was 1. And it tells you that occur at 3 pi over 2 plus 2 pi over k and pi over 2 plus 2 pi over k for all integers. That's where my minimum and my maximum values are happening. Okay? The domain, so this is a max, this is a min. The domain of the sine of x is equal to -infinity to +infinity. I can plug any number I want to in for x. The range, that's my amplitude, okay? So I see that the smallest y value is -1, the highest y value was +1. So the range is from -1 to 1 in brackets. The graph of f of x equals sine x has a midline at y equals 0, amplitude of 1. There's a little shortcut that I like to give you when we're graphing sine. That's O max, O min, O. So if we come back over here and look at this graph, I start at an O, then I go to a maximum, then I go to a minimum, and I go to an O, minimum, and then back to an O. So O max, O min, O. Then I repeat itself. Max, O, min, O. So I could just keep doing that. So again, O, max, O, min, O. This is for the sine of x. We'll always have that pattern. So now we're going to talk about cosine. So we want to find the period, the domain, the range, the midline, and the amplitude of cosine of x. So again, I'm going to make my xy table. I'm going to use 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, the exact same x's that we used for the sine. So if I plug in 0, the cosine at 0 is 1. The cosine at pi over 2 is 0. The cosine at pi is -1. The cosine at 3 pi over 2 is 0. The cosine at 2 pi is 1. The cosine at 5 pi over 2 is 0. Again, I notice repeats itself, starts over. So therefore, it has a period of 2 pi as well. My domain, again, I can plug anything I want to in, negative infinity to infinity. Let's look at this graph, and then we'll talk about the rest of that. So I have a 1 and a negative 1. And so I've got pi over 2, pi, 3 pi over 2, 2 pi, I wanted to keep going, 5 pi over 2. So at 0, I was up here at 1. Pi over 2, I'm at 0. Pi, negative 1, 0, 1, came back down. So my cosine, 1 full looks like this, but then I know it would keep going. So the cosine, okay, starts at a maximum, goes to an O, minimum, O, maximum. So it's a little shortcut, max, O, min, O, max. I see that my range is negative 1 to 1. My midline is still y equals 0, and I have an amplitude of 1. So now let's change some things up. What are the amplitude and period of f of x equals 3 cosine of x? Again, I can make an xy table. Again, I'm going to pick 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. So if I plug in 0, the cosine at 0 is 1, but now I have to multiply it by 3, so I get 3. The cosine at pi over 2 was 0. When I multiply that by 3, I get 0. The cosine at pi is negative 1 times 3 is negative 3. 3 pi over 2 is going to get me 0. 2 pi, I'm going to start repeating itself, 3, 0. So this is 3, negative 3. So I'm starting up here, max, O, min, O, max. So this is what I know that it looks like. I wanted to come the other direction, so start at max, O, min, O, max. So I know what it would look like. So my amplitude, this time the height, if I look at my midline, is still y equals 0. My height now is 3, so my amplitude is 3. My period is still 2 pi. My domain is still negative infinity to infinity, but this time the range of this graph goes from negative 3 to 3. It tells us, as with other functions, the graph of y equals negative f of x is a reflection of the graph of the parent function over the x-axis. As with other functions, the graph of y equals f of 2 times x is going to be a horizontal compression of the graph of the parent function by a factor of 1/2. So a equals sine of bx, y equals a times the cosine of bx. A is going to either be a vertical stretch or compression. B is a horizontal stretch or compression. The absolute value of a is our amplitude. B is equal to the number of cycles by 2 pi. So we can use this formula, the period equals 2 pi over b, to find the period of any of these functions. Okay. So let's try that. So it says, what are the amplitude and period of y equals negative sine of 2x? And again, at the end, we're going to go in and graph this. So I know that negative a means it reflects over the x-axis. So my little shortcut, instead of O max, O min O for sine, it's now going to be O min O max O. So it's just going to reflect. Okay? The absolute value of A is my amplitude 1. My period, I'm going to use the equation 2 pi over b. My b is 2 equals pi. That b is 2. The b tells me I have a horizontal compression. Since it's a 2, it's by a factor of 1/2. Since it has a period of pi, again, I need 5 sections on my graph. So 5 sections start at 0. We always start at 0. End at pi this time. Okay? So here's my graph. Here's my 0. Okay? So now I know I'm going to end at pi. Okay? So I need 1, 2, 3, 4, 5. Halfway between 0 and pi, I know here is pi over 2. Halfway between 0 and pi over 2, I know is pi over 4. So then this would be 3 pi over 4. I know I'm going a 1 and a negative 1. Since it was a reflection, now I know that I'm starting at down here at, sorry, still starting at my minimum for sine. Sorry about that. So O min, O max, O. So this is what this graph would look like. And again, I could continue drawing this in either direction by following that same pattern. So the second one, what are the amplitude and the period of y equals 1/3 cosine 1/2 x? I see my amplitude is 1/3, so that means the height of my graph. The period, so here, let's see, 2 pi over b is 1/2. Flip and multiply to get that out of the denominator, and I get a period of 4 pi. So if I were to graph this, starting at 0, I'm going to end way out here at 4 pi. So 1, 2, 3, 4, 5 sections. So all of these are just going to be pi. Here's pi, 2 pi, and 3 pi. If this is 1 and negative 1, oops, sorry, negative 1, then this would be like 1/3 and negative 1/3. So I'm using my little shortcut for cosine. So cosine means I start at my maximum. So max, O, min, O, max. So here's what the graph looks like. Again, I could still see my domain is still negative infinity to infinity. This time my range on this one would be negative 1/3 to positive 1/3. So now let's look at what are the amplitude and the period of y equals 2 sine pi x. Again, I see my amplitude is 2. The period, if I use the formula, 2 pi over my b was pi, my period is 2. So this time, if I were to draw this out, I'm going to stop out here at 2. I'm not using pi anymore. So this is 0, this 1, 2. Okay? So I need 1, 2, 3, 4, 5. So this would be 1/2, and this would be 3/2. I need an amplitude up to 2 and negative 2. Doing my shortcut for sine is O max, O min, O. So this is what that graph would look like. And again, I could continue going. My range on this one would be negative 2 to 2. My domain is still going to be negative infinity to infinity. Right, so now we're going to talk about what's called a frequency. So frequency is the reciprocal of the period. So y equals sine x and y equals cosine of x each have a period of 2 pi. If I flip that, that means the frequency is 1 over 2 pi. The function repeats itself one time from 0 to 2 pi. Okay? So y equals negative sine 2x has a period of pi and a frequency of 1 over pi because the function repeats itself one time from 0 to pi. And that's just what this is showing you here. Okay? So repeats itself, okay, one time. Right. So on the back, what is the frequency of the graph y equals 5 times the sine of 1/2 x? So first we're going to identify the transformations from the parent. We're going to interpret the parameters to identify the amplitude and the period, and then we're going to sketch it. Okay, so identify the transformations. So basically that's part A and part B. So my amplitude is 5. My period, again, 2 pi over 1/2, I know is going to give me 4 pi. So my frequency is 1 over 4 pi. This 5 also tells me that A is going to give it a vertical stretch. Okay, so we want to sketch the graph. So this time we need to end out here at 4 pi. So 1, 2, 3, 4, 5. So each of these are pi. So pi, 2 pi, 3 pi. We need to go from 5 to -5. And again, if I do my little shortcut for sine, okay, I know that I start at O, O, max, O, min, O. Right, so now last thing we're going to look at, how does the average rate of change differ within one period of the function y equals 5 times the sine of 1/2 x? So remember, average rate of change is just like slope, right? Over here, when it says average rate of change, we're going to do y2 minus y1 over x2 minus x1. So we want to check the interval from 0 to pi. I need my endpoints. So at 0, what is my graph doing? What's the point? 0, 0. At pi, what are my endpoints? This is up at 5. So my endpoints are pi comma 5. So we'll go through and just find all of our endpoints first. So at pi, I know I'm at pi comma 5. At 2 pi, we see we're at 2 pi comma 0. 0, 0 again. 2 pi 0. 2 pi 0. 3 pi. So at 3 pi, we're down here at -5. 0, 0. 4 pi, what's the y value? 0. So now my average rate of change, I'm just doing y2 minus y1. So y2 is 5. 5 minus 0 over x2 minus x1, pi minus 0. I get 5 over pi. So my average rate of change is 5 over pi. On the interval from pi to 2 pi, again, y2, 0 minus y1, 5 over 2 pi minus pi. It's -5 over pi. So the average rate of change on that interval is -5 over pi. On the interval from 0 to 2 pi, I would have 0 minus 0 over 2 pi minus 0, which is just going to get me 0. From 2 pi to 3 pi, so I have -5 minus 0 over 3 pi minus 2 pi. So -5 minus 0 is -5. 3 pi minus 2 pi is pi, so -5 over pi. 0 to 4 pi, so I'm going to have 0 minus 0 over 4 pi minus 0, which gets me 0 over 4 pi, which gets me 0. So that's how we find average rate of change. So now let's look at graph y equals 3/2 cosine 3 pi x. And what is the frequency? So right off the bat, I know my amplitude is 3/2. The period is going to be 2 pi divided by 3 pi, which is going to be 2/3, which means the frequency is 3/2. So if I want to graph this, so 1, 2, 3, 4, 5, this is 2/3 because that's my period. So halfway between 0 and 2/3 is 1/3. Halfway between 0 and 1/3 is 1/6. Halfway between 1/6 and 2/3 is 2/6, or 3/6, which is 1/2. This is 1, and this is -1. Our amplitude is 3/2. So this is like 3/2 up here, -3/2. Cosine means I start at my maximum. So max, O, min, O, max. Okay. So now we're going to find our average rate of change of that graph over the interval 0 to 1. So I need my endpoints. Okay? At 0, my y value is 3/2. So I have the endpoint 0, 3/2. At 1, I don't have 1 on here, but I could continue, right? So if I went 2/3, or I could just plug it in up here. So 3/2 times the cosine of 3 pi times 1, which is 3/2 times the cosine of 3 pi, So 3 pi, I know is the same thing as pi. At pi, my cosine is -1, so 3 halves times -1 is -3 halves. So this is going to be -3 halves. So my average rate of change, -3 halves minus 3 halves over 1 minus 0. So this turns to -6 halves over 1, which turns to -3. So my average rate of change is negative. If I had wanted to continue this using the graph, right? So I see each of my intervals are 1/6, right? So this is 1/6, this is really 2/6, 3/6, 4/6, so then I would have had 5/6 and 6/6, which is 1, right? So I'm up here at max, so then I would have gone O min. So if I had continued my graph, and so then I see at 1, my y value was -3 halves. Okay, so it just depends on how you want to find your endpoints, whether looking at the graph or just plugging them in. All right, so that is our first day of graphing sine and cosine. Next, we will look at graphing tangent, cotangent, secant, and cosecant, and then we'll look at graphing transformations. We only graphed one cycle, but again, if I wanted to continue on and get 2 cycles, 3 cycles on my graph, I would just continue all of my graphs out and continue my pattern. Yeah.